Stuxnet is the first worm to target an industrial control system, such as a gas pipeline or a power plant. The attack likely started when an infected USB key was physically brought into the target environment, perhaps by an unknowing third-party contractor or by an insider. Once inside the environment, Stuxnet would infect an employee's computer. This employee would unknowingly spread it to other coworkers' computers when sharing USB keys. In addition, Stuxnet could spread on the local area network using network shares and 2 exploits. Stuxnet's goal is to find a computer in the organization that is used to program a PLC, or a programmable logic controller. A PLC is a small computer that can control industrial machinery such as pumps and centrifuges. Every time a computer is infected, it sends a message back to the attacker over the internet, which provides the attacker with general system information. The attacker can then tell the computer to spread Stuxnet further until it finds a computer that is able to program the targeted PLC. The attacker then steals design documents to determine how to sabotage the industrial control system. Once they have those design documents, they are then able to send code to the infected system, sabotaging it. For example, the code sent can result in a pipeline exploding or a centrifuge spinning out of control. We obtained a PLC in order to demonstrate how this might work. In the following video shot in our lab, Liam Omuraku demonstrates how this might play out.
Hello, I'm Liam Omuraku from Semantic Security Response, and today I wanted to talk about the demonstration that we gave at Virus Bulletin where we showed infection of a PLC. I'm going to do that demonstration again today, and what I have here on the table is I have the laptop that has the Step 7 software installed, and you need that software in order to access the PLC and to program the PLC. Here's the PLC that we're actually going to program. We're going to download our program on here and we're going to show how we can control the PLC. The PLC is connected to this air pump, and we're going to use this air pump to inflate balloons, and we're going to use proof of concept code to show how Stuxnet would be capable of interfering with the process of programming the PLC and controlling the pump. So the demonstration that I'm going to show is I'm going to program the PLC to inflate this balloon for 3 seconds. Then we're going to infect the PLC, and we're going to download the same program to inflate the balloon for 3 seconds again. But when the computer is infected, you'll see that the PLC behaves differently from what we expect. So to program the initial PLC to inflate the balloon for 3 seconds, I use the software Step 7. So in Step 7, you need to open up the code block OB1, and inside in the code block OB1, I have this timer here set for 3 seconds. 3S is the important command here. This timer is going to run for 3 seconds. It'll turn the pump on until this timer is finished, and when the timer is finished, it'll turn the pump off. That's turning the pump off here. So what I do is I download that onto the PLC, and it asks me, do I want to override the code that is already there? I say yes. Okay, so now this code is on the PLC, so we can test our code out by turning on the PLC. So we see that the code worked as we expected it to work. The balloon inflated for 3 seconds. So now what we're going to do is we're going to infect the PLC. We're going to infect the computer here. We're going to download the same program onto the PLC, and we'll see that the PLC behaves differently the next time. So to do that, I need to close all the software, infect the machine, and then open up the software and perform the same steps again. So here again, we look at OB1. We see that our code still says 3 seconds, and we're going to download this onto the PLC again. At this stage, the computer is infected, so we don't have control of the PLC. So what we think we're sending to the PLC can be intercepted by the threat and can be rewritten. So it's asking me, do I want to overwrite the code that's already there? I say yes, the same as last time. So now this code here that will run for 3 seconds and inflate the balloon for 3 seconds, that's what we should observe here when we turn on the PLC. see that the PLC did not actually run for 3 seconds, it ran indefinitely, which caused the balloon to explode. So what we've shown here is that using the techniques used by Stuxnet, it's capable to reprogram PLC to operate in a way that you would not expect and operate in a way that you did not program it to operate. This could have very serious consequences in a real-world situation.